So hello, bro. This is probability and stochastic homework set and question 2. So this question had 3 parts. For the first part, it requires us to find b so that the above defined function is a valid non-density function. So firstly, we can sketch the graph like this. As x square plus y square smaller than 1, we can sketch the circular and its r is equal to 1. So we can make an integration for this part. So hence we can list this function. And as we know that the area of this circular is pi is equal to pi times r square, and r equals to 1, so the area is pi. So as we know that the non-density function is equal to b, so it can be written as pi times b equals to 1. So the b is equals to 1 over pi. So this is the first part. As for the second part, it requires us to find this one, and blah blah blah. So firstly, we can start from the first one, ax. So from the definition, we can list the formula like this format. So through the integration and calculation in the series, we can calculate. We can derive this function. We can derive that ax is equal to 0. As we can see that. So as ax is equal to 0, so it is easy to see that ax if y is equal to 0 and ax if y is equal to 0. So it is easy to see that. And then as x, y is symmetric, so we know that ey is equal to ax equals to 0. So if ey equals to 0, then ay if x and ey if x equals to 0. So the second part, all the also I know consequence is equals to 0. Oh, sorry. We also need to calculate the axy. So we can through the definition, we know that axy is equal to this part, and through the series calculation, we know that it also equals to 0. So all the elements is equal to 0. So this is the second part. And then for the third part, it requires us to prove or disprove x and y are uncorrelated. So for the definition, we know that we need to prove that whether axy is equal to ax times ey or not. So we have know that axy equals to 0 and ax equals to ey equals to 0. So we know that this formula is right, it's accurate. So we know that so from the definition, we know that x, y are uncorrelated. Yes, that's all.